Let's talk about Newton's first law of motion, which most of you are probably very familiar with. It says that objects will keep their state of motion unless they're acted on by an outside force. What do we mean by state of motion? We mean that it's going to keep doing whatever it's doing until a force makes it change. So that means that nothing will speed up, slow down, or change directions unless a force makes it do so. These things we collectively call acceleration. So nothing will accelerate unless it's forced to. So if something is at rest, meaning not moving, it will stay at rest. If something is moving at a particular speed, if something is moving at 1 meter per second, it will continue moving at 1 meter per second until some force makes it change direction, speed up, slow down, come to a stop, whatever it is. Let's look at this animation. Here we've got a car with a driver. The car hits a wall, but you notice that the driver does not stop when the car stops. That's because the force the force of the wall stopped the car, but it did not stop this driver, so the driver continues moving. Right? Let's look at it again. The car is moving, the driver is also moving. When the car is stopped, nothing stopped the driver because he apparently did not have a seatbelt on, and so he continues to move and flies out of the car. We can also look at it on another simulation. Same thing. Here we've got a truck with a ladder on the top. As the ladder moves, the truck is suddenly stopped. The collision of the truck with the car stops the truck, but it doesn't stop this ladder that's up on top of the truck. That ladder continues to move because no outside force or no unbalanced force has acted on the ladder, only on the truck. This law is sometimes referred to as the law of inertia, Newton's first law. And inertia is simply an object's resistance to changes in motion. Meaning that once objects start moving, they will want to continue moving. And once objects are at rest, they will want to remain at rest. It will be difficult to change their motion. That's inertia. Inertia, it is important to point out, is a property. It is not a force. It is directly related to the object's mass, which tells us that the greater the mass of an object, the greater the inertia. Right? So in other words, something that has a lot of mass is going to be more difficult to change its motion than something that has less mass. So let's answer these questions. Which has greater inertia, a bowling ball or a golf ball? Well, how can we figure that out? We know that inertia is directly related to mass. The more mass, the more inertia. So, which one has more mass, a bowling ball or a golf ball? The bowling ball has more mass, so it's going to also have more inertia. Right? So then, which one, the bowling ball or the golf ball, would require greater force in order to change its motion? Well, anything that has greater inertia is going to require greater force to make it change its motion. That's what inertia is. It's the resistance to change in motion. So, if a bowling ball has more inertia, then it's going to also require greater force to change its motion because it has more inertia. What if this bowling ball were in space? Would it still require force to make it change its motion? In outer space, we've got no friction because would be just floating around. It wouldn't be a surface rubbing another surface. No air resistance and no gravity pulling it down. Would it still require a force to make it move? Yes, it would. It would still require force because it still has mass, which means it still has inertia. And the bowling ball would still have more inertia than the golf ball, even in space, because the mass hasn't changed when you go to space, so neither has the amount of inertia, right? So in your notes, you should know the first law. You should be able to state it. You should be able to give an example. You should be able to tell me what it means. And relate this to acceleration. You should be able to tell me about inertia, what it is, and you should be able to compare the inertia of different objects based on their mass. If you do not have these things in your notes, please go back and put them in your notes.